Good morning once again. This is Mr. Herman. The past few videos that we've looked at have dealt with recursive formulas. Okay, this is the last in our recursive formula series, so to speak. We've talked about the basics of what our equations look like for arithmetic and geometric recursive formulas. We've looked at using our arithmetic recursive formulas, and now we're going to take a look at using our geometric recursive formulas. Okay, they work very similarly to our arithmetic recursive formulas. Except rather than having our common difference, we have a common ratio. Okay, so without further ado, let's go ahead and get started on those problems that are in our notes here. So we have the equation a1 equals -4 and an equals 1/4 times a sub n minus 1. Okay, so once again, an minus 1, there's that notation coming up again. This is this term that we've got right now. We're trying to find n. So if we have n as maybe our 7th term, we have to use our 6th term to find that 7th term. All right, so we're going to write the first 5 terms of this sequence. Okay, call that part A. So our first 5 terms, first term, we're always going to be told that first term. Okay, now sometimes this might not be the first term, but most of the time that we'll see, it will be A1, the first term. It could be A2, it could be A7, but most of the time it's going to be that first term. Okay, so we've got A1 is -4. I got to figure out what our pattern is. I'll label that our first term. Our pattern, let's go ahead and pull out our geometric recursive formula sheet. So we said that it's going to be, so we got an equals an minus 1 times or divided by r, our common ratio. Okay, now in this case, the order's changed up a little bit. We have 1/4 times an minus 1 rather than an minus 1 times our common ratio. However, that doesn't matter because we can switch the order that we multiply. 2 times 3 is the same as 3 times 2. Okay, so it's going to be just fine. So that tells us though that our pattern, okay, I'll draw in here, that's our common ratio. Our pattern will be dividing by 4 each time. Okay, so we're going to, or we multiply by 1/4. I'm going to multiply by 1/4. That's what the formula tells us. So times 1/4, that gives us -1, times 1/4, that's going to give us -0.25, times 1/4, and some small numbers here, negative point, I'm just in my head, 0.625, I believe. Yes. Let's see, that's 4. Let's go ahead and do our 5th one here. We'll be negative still. 0, 1, 5, 7, 5. I think so. It's approximately that. I have to get my calculator out. No, we won't worry about that though. So what we're doing there then is we're just multiplying by 1/4 each time. Okay, now in part B, we're asked to get to our 6th term in the sequence. Okay, so we've got A1, we've got A2, we've got A3, we've got A4, we've got A5. We got to find A6. In fact, we are ready to go given what we just found, but if we had not already found these first 5 terms, then we'd have a little problem here. Okay, we would not be able to answer this question without finding those first 5 terms. All right, so let's take a look. See, actually, I'm gonna fix this to be 1. And it's 5, and then 6, 2, 5. Okay, it's -0.015625. All right, so now we got to find, we got A5 equals -0.015625. Let's go down here and say A6 is -0.015625 times 1/4. That's going to equal, okay, -0, or 0.003 9 0 625. Okay. Once we get past 0.0625, I recommend checking this in your calculator. I'm pretty sure that this is correct, but as the idea of what we're doing is we can put this in our calculator, that's fine. We're just making sure that we can do our common ratio each time. That's what this recursive formula is telling us. We're starting at -4, and we're multiplying by that common ratio every single time to find that next term. Let's go on to our next problem. -2, 1, 4, 7, 10. Okay, so like on the last one, we checked to see if it was an arithmetic sequence, and then we checked to see if it was geometric. Once you've seen these for a while, you might be able to eyeball and say, I think I see a certain pattern going on. I want to check that one first. Okay, so I usually check our arithmetic first and then geometric, unless I'm pretty sure that there's one going on there. So let's check our arithmetic first, just to see if we've got something. I suspect that we might. So we've got 1 minus -2, and we've got +3. Let's check here. So we've got 4 minus 1 plus 3. One more for good measure. 7 minus 4 plus 3. Okay. So this is arithmetic with a common difference of +3. All right. So now we are trying to write a recursive formula for this sequence. Now I want to write our other kind of formula. We wrote an equals an minus 1 on the last time. Let's take a look at a different, our other format. So first we got a1, has to give us that first term. So what we're starting with -2. And that first term is -2 there. Now, I want to use the format an plus 1 equals an. Last time we said an equals an minus 1, which is fine. They're both the same. They both tell us the same thing. It's a different way of writing it. I want us to be exposed to both kinds, so we can see either of those in the EOC. All right, so we've got an plus 1 equals an, and what's going to happen in order for us to find that next term? We got to look at our pattern. All right, so our pattern here is our common difference of +3, so that's what we're going to do every single time to find that next term, that an plus 1. So we take that term that we've got, we're going to add 3 to it, and that's going to find the next term every single time. Okay, that's just telling us that if we got a term, we want to find the one that comes after it. What do we got to do? We got to add 3 to it. Okay. So that's going to be an explicit formula, or not explicit, rather recursive formula, my bad, for this sequence. All right, now we're going to go over to number 3 where we will be writing an explicit formula. Okay, so here we've got a geometric sequence. I can tell that because we're multiplying by 1/7. Okay, so we're going to go ahead and write the first 5 terms of this sequence, then we're going to write an explicit formula. Okay, this one you might want to break out the calculator because we're working with kind of big numbers and dividing by an awkward number that's 7. Okay, I'm going to see how much I can do without a calculator because I don't have one with me right now. But I would encourage you to use one just to check my work. Hey, if I'm making mistakes, that's fine. It means that we're learning. Okay, so we got A. Got the first 5 terms. First term, we're always going to give that first term 17,649. Okay, now we're going to divide that number by 7. We're going to get 1, 6. Let's see, 16807. Okay, that's our second term. I'll just label them A1, A2. We'll go ahead and find A3, which is going to be 2,401. There's A3. Let's go ahead for A4, which will be 343, and then A5, which will be 49. Okay, that's nice, neat numbers, no decimals in there. We've got those first 5 terms. We said multiply by 1/7 each time, so times 1/7. Times 1/7, okay, times 1/7. Now let's go ahead and write our explicit formula. So we said this is our first term. I'm going to go back to the top. First term. And there's our common ratio. There's our pattern that we're using. Okay, so we're using that pattern. Let's pull up our explicit geometric formula, which is going to be an equals a1 r to the n minus 1. So we've got A1 is 117,649, and we've got r equal to 1 over 7. We're going to plug that all into our formula here, and we're going to call it a day. We've got AN equals 117,649. Put that in parentheses just to make sure we can distinguish it there. And then in our parentheses here, we got 1 over 7, our common ratio. And then keep that n minus 1, that's going to tell us what term are we looking for. And then AN is going to tell us what is the value of that term. Okay, so now we've gone through what recursive formulas look like, what those equations are, and then also how we can use them to find some terms and also to rewrite into explicit formulas. So at this point, you should have hopefully a good understanding to at least start the assignment that's on the back of this notes page. So once you finish that, you're going to turn that in at the end of class today, so that I can look over that and see what we need to talk about when we come back to class next week. All right. Thank you for watching. Thank you for listening. And good luck on what you're doing. I'm looking forward to seeing what we have learned so far. Thanks.